Alrighty, why don't we go ahead and get started? So, welcome to Intro to Python. Also, welcome to Pycon. Raise your hand if it's your first time at Pycon. Amazing, awesome. So, well, this is a really this is my favorite part of Python to teach, and it's a really great way to get into PyCon the conference as well. So, I hope you have a really good time here, and I'm excited for PyCon 2014 in Montreal, which is a really fun city. My name is Jessica. I definitely use Python every day at work. I actually, my company Zulip was actually just acquired by Dropbox. So I used to live in Boston until a week ago, and now I live in San Francisco and flew out here from San Francisco. But I use Python every day at work. I did at Zulip and Dropbox. If you use Dropbox, much of the Dropbox client is written in Python as well. I am also a director for the Python Software Foundation, which is the stewarding organization behind the Python programming language. We do a lot of community outreach. We're a 501c3 nonprofit. We fund a lot of really great initiatives within the community. And I was also an organizer for the Boston Python user group, which happens to be the largest Python user group in the world. And I still am helping organize that user group as well as getting to know the San Francisco folks. We are joined today by two lovely assistants, Adam and Dana. Hi, Adam. Hi, Dana. Do you want to maybe say a sentence or two about who you are, what you do, why Python is great? Awesome.
My name is Adam Fletcher. I work at Google, where I'm a site reliability engineer, and we use Python for everything. The original version used was built in Python, but we use it for many, many internal tools, and we run lots of computers using lots of stuff written in Python. I help out at the Boston Python workshop as of a week ago.
Adam's also my husband, just FYI. They'll be on the lookout for people who have that confused look to the, yeah. All right, so here's our game plan for today. We have about 3 hours, and we're going to, so my goal for this class is that you leave with a really good foundation in the fundamentals of both programming and Python, and with really clear next steps for continuing to learn and practice the language. So to that end, we're gonna have a bunch of interactive practice together. So learning the concepts interactively, actually going through the exercise of breaking down and solving problems in Python to really bridge you to the next sort of level of practice. So we're going to have some interactive lectures and then some sort of self-paced online practice problems, and then a pretty solid wrap-up to make sure you know what to do next to continue practicing. So that is the game plan for today. Does everyone have a handout? Great. Okay, well, we're going to dive right in then because we only have 3 hours. So if you could please, make sure that you know how to pull up a terminal while I give a little pitch for, no, that's not what I meant to do, for why Python is so great. Here we go. And advance. No? Okay. Now my screen is just white, and it's not, oh, okay. Here we go. I'm gonna delete this. I'm gonna play this. Thinking about it. All right, what can you do with Python? So we all use Python every day at work, but why Python specifically as an investment in a programming language that you're going to learn? And there are a lot of good reasons. Python is an exceptionally versatile language, so you learn it and you're able to do useful work across a wide variety of domains, and we'll see some of them here. It's also a really easy language to learn, and because of those two reasons, actually a lot of academic institutions are switching to Python. So For example, MIT made the switch to Python as its, not only its intro language, but the language that it teaches a lot of its core classes in a couple of years ago. So it's a very popular language. It's already popular, but it continues to increase in popularity and get a stronger and stronger community, which means that it's a language with a lot of job opportunities. All of the cool projects are written in Python. You will have lots of people to collaborate with on projects because it's such a robust community. Some specific examples of things that you can do. If you've ever wanted to build a website, Python is a great language to do that in. There's a particular Python module or library, sort of a collection of functionality built on top of Python for building websites. That library is called Django. And if you've ever used Instagram or any Pinterest users here, or if you visited the Mozilla website, these are all websites that were written in Python in Django. If you've ever wanted to write a game, you can do that in Python. So in the lower right-hand corner, this is a 3D Minecraft clone written in Pygame using a 3D graphics library called Piglet. And then in the lower left, this is a like rock band, open source rock band clone written entirely in Python. And so you can like skin it yourself, add new songs. It's totally customizable because it's all open source and programmed in Python. Python is super popular in the sciences. And so in particular for like data visualization and data analysis, some really strong libraries for doing these things. If you've ever used Excel and hated Excel, or like it can't handle the volume of data that you're working with, or the graphs just don't look quite right, imagine having sort of infinite flexibility because it's in a programming language that you know. You can even make sort of videos of graphs in Python using this matplotlib library. Yeah, so really popular in the sciences. In addition to sort of generically for data analysis and visualization, a lot of the scientific computing tools are scriptable in Python. So for example, this little rotating molecule here was generated by a Python script that is programming this PyMol molecular simulation environment. So it's a good example of like Python being a scripting language that plugs into existing systems. And I think it's worth reminding ourselves that Python is actually, or programming in general, is a deeply creative endeavor. So not only can you crunch numbers, and analyze large volumes of data with programming languages with Python, but you can also do things like make music and make art. It's a collaborative process, it's a creative process, and you can even do creative things, with programming. Python is exceptionally good for interacting with hardware. Have people heard of the Raspberry Pi? So it's this awesome, so it's like a $25 computer. And people are really excited about this because if it's $25, it means you can give it to kids and they can do whatever they want with it, and it's okay if they break it, right? And you can use the Raspberry Pi and you can sort of connect it to little peripherals like sensors, like LEDs to do cool projects. And the Raspberry Pi decided to make its programming environment be based on Python. So Python is sort of the programming language for the Raspberry Pi. So if you want to play with hardware, make robots, make LEDs blink, Python is a really great language for that as well. So when people ask me what can you do with Python, the answer is really just about anything. So it's a really versatile language, really low syntactic overhead, so a really great investment as not only a first language, but a language to actually get useful work done in. So that's my pitch to you. And with that, we're going to go ahead and start learning it. So if folks could pull up a terminal, raise your hand if you don't remember how to do that. So if you could pull up a terminal, let's start Python. Just so we know that we're at the terminal because of a prompt that looks like this. And if we type Python and we press return, we see that we're taken to this caret interpreter, and this is how we know that we're inside of Python. So everyone get to this point. And we have to crawl before we can walk, so we're going to start learning Python by using Python as a calculator. And as we do this, I ask that you actually type along with me. And this sounds goofy, but when you type along with me, your fingers are going to get used to what it feels like to type in Python programs, and that's going to be really helpful for developing this fluency. So please do actually type along with me. Okay, but Python as a calculator. You can do basic math. So 2 plus 2 equals 4. 1.5 plus 2.25 equals 3.65. You can do subtraction. You can do multiplication. So basic math works about as you would expect. Division looks pretty normal. There's a funny little caveat here about division, which is that, okay, so 4 divided by 2 does equal 2. What does 1 divided by 2 equal? Well, I know what you and I think. Python thinks it equals 0, which is a little funny. And what's going on here in Python is that Python is being sort of very specific about what kind of division you want to do. It says, oh, you have this whole number 1 dividing this whole number 2. I think that what you want out is a whole number. So it sort of truncates down to the nearest whole number. If we wanted to do the division that we expected, sort of the natural division that we expected, we'd have to make one of those numbers care about a decimal place. So this will work as we expect. So one tiny caveat, but otherwise math basically works as expected. The spacing doesn't matter. So 2 plus 2 is the same as 2 plus 2 with no spaces. And in general, white space, sort of in between expressions, doesn't matter in Python. And you can use parentheses to group orders of operations like you would in math class. So I could say, 1 plus 3 times 4, if I wanted to force the plus to happen first. We can use variables like in math class. Hopefully that doesn't bring up bad memories. But so like you could say x equals 4, right? Now x is a pointer to 4 after we run this. And now I can use x in further computation. So I could say, okay, given that x now equals 4, what is x times 3? The rules for naming variables are pretty simple. It needs to be one word, or effectively one word. Like you can have underscores. And it needs to start with a letter. So I could say, I could use x, that's a valid variable name. I could also say, cups of flour equals 5. It's a fine variable name. In general, descriptive variable names are a good idea because when we're going back and reading our code, or other people are reading our code, hopefully the variable names make sense. Then I could say, okay, cups of flour times 0.5. Right? Now, what about this 1 divided by 2 thing? And why is it that 1.0 divided by 2 is different? Well, as it turns out, that Python actually considers these as 2 different types of objects, 2 different data types. And we can actually test this using this thing called a function. Let's type this out and then we'll talk about what's going on. So there's this thing called a function. Functions have a name. In this case, the name is type. And then it has the inputs in parentheses. So this is a function called type that has one argument inside parentheses, and this argument is the number 1. And if we use this type function and take the number 1 as input, and we press return, the output tells us what Python considers the type of this object. In this case, it thinks the type is that it's an integer, or a whole number. Now, what about the type of 1.0? Python says this is a float. Cool. So this helps explain the division difference. So Python knows, in this case, that when you do 1 divided by 2, we're dividing 2 integers, and integers don't understand decimal places. They only care about whole numbers. When we deal with floats, at least one float, then we get to care about the decimal place. So something to keep in mind when doing math. But also an excuse to talk about this idea, which is the idea of a function. And a function is just a name given to a useful bit of computation. It takes input inside parentheses and produces output. Any questions about math, integers, floats? Okay, another really basic and useful data type is called a string. And a string is just what Python calls a bunch of characters. This is like numbers and letters and punctuation put together. Strings are indicated by being surrounded by quotes. So, for example, this is a string. Can people see this in the back, or is this too low? A little. Okay, let me pull it up a little bit. Oops. Come on. There we go. Okay. So hello inside quotes is a string. So I could also say, you know, Python. So even with white space, even with numbers, if it's inside quotes, it is a string. Okay. Like with the math data types, we can use this type function to check what data type Python thinks this is. So we can say type, and then inside the parentheses, something like hello. And we see that, in fact, Python considers this a string. Now, cooler than in math class is that we're not just restricted to assigning variables to numbers. You can assign a variable name to anything, including a string. So I could say, okay, name equals Jessica. And then I can use name in further computation. You can concatenate or smoosh together strings with a plus sign. So I can add numbers, right? Well, I can also add strings. So I could say, okay, Jessica plus McKellar, and this is my name, right? And the plus sign is going to concatenate these two strings. Now, Python is really literal about this. So when I add them together, there's no space added. So if I wanted a space between my first and last names, I could fix this in at least one of two ways. I could say, okay, Jessica with a space at the end plus McKellar. Or I can actually use as many plus signs as I want to concatenate a bunch of strings in a row. So I could say Jessica plus a space plus McKellar. As long as we're really careful about having all of the quotes and the pluses in place, right? So you need the beginning and ending quote, and then a plus, beginning and ending quote, plus, beginning and ending quote. And I could use, I can use variables, right? So I said name equals Jessica. So I can also concatenate strings that are pointed to by variables, right? So I could say my name is plus name. A tip for us as we're going through stuff in the interactive interpreters, you can use the arrow key to arrow up through previous things that you've executed. So that can save us some typing. We can maybe arrow back up and then edit something and rerun it. Okay, so strings exist. They're indicated by quotes, and we can concatenate them. What about this? We can add numbers. We can add strings. What do you think this does? Guess? It could be hello one, totally a plausible thing. Well, let's find out. Let's see what happens. Oof. So Python didn't like that, but that's okay. Python has given us a traceback. It says, hey, you did something I didn't understand. And then it gives us a helpful error message to understand what went wrong. In this case, it says, oh, there was a type error. I don't know how to concatenate strings and integers. Fair enough. I can buy that. And this is important because we'll see these all the time. Like I'll typo something, we'll be writing a program, we'll mess something up, and we'll see these tracebacks. And sort of the thing to understand here is not to be intimidated by them. No problem, we'll just fix whatever the problem was and then get on with our lives. Okay, so hello plus one didn't quite work. What if we really wanted, though, to concatenate these two ideas into one string? How do we do this? Well, we have a couple of options here. One is we could have put the one in quotes, right? Because a one in quotes, even though it's a number, it's in quotes, it's actually a string, right? So that would work, and we can confirm this. So the type of one is an integer. The type of one in quotes is a string, right? Another thing we could have done is use a new function that will convert a number into a string. It's called str, short for string, and then it's a function, so it has a name, and then it takes input inside parentheses, and it turns that into a string. And so what Python does when it sees this line is it says, okay, 1, this is a number. You want to turn it into a string. I'm going to do that first. Then I see that you want to concatenate these two strings, so then I'll do that for you to give you the overall string. So Python sort of unpacks these things one at a time until everything has been unpacked and evaluated. Strings have a length. And we can access the length using another function called len. And len can operate sort of directly on strings, or as always, you can use variables that point to strings. So I could also say the len of name. So we could pair this idea with this idea. So we could say, you know, the length of my name is the str of, getting a little fancy here, the len of name. So let's unpack that. What happens first? Name points to a string that is my name, Jessica. We get the length of it. Jessica, 7. 7. We take the string representation of 7. We then concatenate these two strings. And then what's the output? So Python can handle sort of arbitrary complexity here. It can unpack as much stuff as you want on a line, depending on what you want to express in code. Astute viewers may have noticed that when I type in hello with 2 quotes, Python is spitting it back out with single quotes. What is up with that? This is just the way that Python chooses to represent it. As it turns out, you can use double quotes or single quotes wrapping strings as long as you're consistent. So hello with double quotes is exactly the same as hello with single quotes. The only place where you have to be careful is about if you have quotes inside the string that you're quoting. So we had this happy camper one from earlier. See if I can find it. Or this one, yeah. We have some quotes inside the string. We have to sort of, Python needs to know what is actually the outside bounds of it. So we use the double quote on the outside, the single quote on the inside, or vice versa. So as long as you're consistent. One kind of funny thing about strings in Python is that you can multiply them. So a lot of the math operations do work. So, you know, what would that look like? Well, okay, A is a string, times 40. There you go. You could say H equals happy, B equals birthday. Let's see if we can unpack this mentally. We could say H plus B times 10. So let's think about what this will do. H plus B times 10. Another thing that I'll mention while we're dealing with strings, and I have to mention this now because we'll use it later, but it'll make more sense once we actually use it in context, is that there's this idea of like intentionally printing strings to users. And right now, we're at this interactive Python interpreter where every time we press enter, Python executes that line of code. But when we're writing longer programs, we're going to do them in files. And when we're here at this interactive interpreter, if I type hello, it echoes it back out to me. But this wouldn't happen inside of a file. When we're running code inside of a file, we have to say, oh, I meant for this to be printed to your eyeballs. And the way that we do that is with another function called print. So it looks really similar, but the thing that's really important is that print is a function we will use to intentionally display output to users. And we're going to use this a lot in longer programs and in programs that we write in files. So you print strings, generally speaking. Just keep that in mind. Any questions about numbers, math, strings, traceback? Yes. Powers, yeah. So let's say that I wanted to take 3 to the 3rd power. The symbol that Python chose for representing this is actually 2 stars. So this is how you take the power of something. So not caret, it's star star. Other questions? So we've learned about 3 data types. And we know this because of this type function. So what is this? It's an integer. What is this? It's a float, which understands a decimal place, which we maybe need to be careful about when we're doing division in particular. And then what is this? A string. Yeah. Cool. Okay. Okay, so we've got some data types. We can do some math. We can print things. That's cool. But what we really want to start being able to do is write longer programs where you can make choices. We're going to need to introduce a new data type that will enable us to make choices. There are 2 of them. We'll type them out and then we'll figure out what's going on. So then we have a capital T true. This is called a Boolean. We have a capital F false. And this is also called a Boolean. And we can confirm this, as always. If we're ever not sure, we can confirm this with that type function. So the type of capital T true is a bool. The type of capital F false is also a bool. And Booleans sort of materialize when we're making comparisons. And they represent, in general, sort of truthiness and falseness of statements that we make in Python. So, for example, let's say that we had the number 0. And we wanted to compare it to the number 0. We wanted to ask the question, is 0 equal to 0? And note that this is equals equals, so 2 equal signs. Is 0 equal to 0? We're asking a comparison question, and Python evaluates this to a Boolean, the capital T true. Now we could also ask the question, is 0 equal to 1? The answer is no, right? Here's how a false pops out. So we use a double equals to check for equality. We use not equals to check for inequality. So is 0 not equal to 1? So is 0 not equal to 1? True. It is true that 0 is not equal to 1. We would expect this to evaluate to true. Here's a question. So a question we might have is Python case sensitive? So like, is lowercase a the same as uppercase a for various computations we might do? Well, we can test this using these comparison operators. So we could say, oh, is lowercase a equal to uppercase a? If we run this, the answer is false, which gives us our answer. Python is case sensitive. It treats these as distinct. You can check greater than and less than, like in math class. So you could say, okay, is 1 greater than 0? This spits out a Boolean true. Is 2 greater than or equal to 3? I'll remind us here that the spacing doesn't matter, although being consistent is good for readability. Is negative 1 less than 0? And is 0.5 less than or equal to 1? Yeah. A kind of cool thing is that you can check for containment using just the in keywords. I could say, it is H in hello. The answer is yes. Is X in hello? Or you can check for a lack of containment with not in. So is A not in A, B, C, D, E? Is A not in A, B, C, D, E? False. And what's cool is that all of these expressions evaluate to only one of 2 things, either true or false. So we can test for equality, we can test if something is greater than or less than, we can check for containment, and they all produce either a capital T true or a capital F false. And we'll be able to use those Booleans to make choices. Okay, so pop quiz, make sure that we're paying attention. So what is the type of this? Boolean. What is the type of this? It's a string. What is the type of this? Exactly, right? So this does not mean anything unless we tell Python that it means something, unless we did a variable assignment. So name error, the name true is not defined. So the capital T in true is important. Cool. How about this? What is the difference between this and this? Exactly. And I guarantee that we will all forget this at least once and then have some hard to find bug in our program. So, but we'll do our best to mentally make a note of, okay, a common mistake is accidentally doing an assignment when we really meant check for equality. Any questions about Booleans, about where they appear? Yeah. Yeah, like what's the deal with that? So these tracebacks will have a similar format whether we're working at this interactive interpreter or writing inside files. And so Python is sort of saying, well, this is like writing in a file, sort of, where it's like each line, it's sort of like a one-line file that we're executing each time we press enter. This falls out of Python using sort of the same internal logic for representing tracebacks, whether or not you're at an interpreter or inside of a file. But if we did this in a file, it would give you the actual line number inside the file where things were. Good question. Oh, another thing I'll point out here is, so we're at this interactive interpreter. It's really great for doodling around, making mistakes, learning features of the language. Everything you do here disappears as soon as you exit from it. So you don't do stuff here that you care about. We'll move into files when we're writing actual programs that we care about. Okay, so we have these Booleans, awesome. Now let's use them to make some choices. And to do this is going to be our first multi-line piece of Python code. So we're going to type it out and then we're going to talk about why it looks the way that it does. Okay, so the simplest way to make a choice in Python is with this new keyword called if. If indicates that we're going to conditionally do something. So if, let's say 6 is greater than 5, colon, return, note that the prompt changes. Python knows that we're in the middle of doing something. Now we're going to indent inside the if, so 1, 2, 3, 4 spaces. Now we're going to use that print keyword. So we're into a case already where we need to say, hey, I mean for this to go to your eyeballs. So use the print to say this is output. We'll print 6 is greater than 5. Okay. If, and then some condition that evaluates to a Boolean. This can be comparison, greater than, less than, containment, anything that evaluates to a Boolean. If Boolean expression, colon, return, indent inside the if, and then we'll print. We'll press return to end the line. Return one more time to say that we're done. And then because this expression was true, the stuff indented inside the if was printed. So what this means is that the stuff indented under the if is executed only if this Boolean condition is true. If this condition is false, we don't even read this. Python just skips to the end of the if block. So, okay, let's try another one. If we say if 0 is greater than 2, colon, return, indent. Okay. So given what we just said, if Boolean condition, colon, indent, print, is this statement true? No. What do we expect to happen when we press return twice? Nothing, right? Python literally doesn't even read this. It doesn't even try to process it. Literally just, oh, I see that this Boolean condition is false, jump to the end. Cool. Okay, but this is great because now we can conditionally do something or not based on some condition. So, you know, one more example. If colon, return, indent. And we can have as much work as we want indented under the if. So we can have many, many lines of Python to execute if this condition is true. We're not restricted to just one line, as long as it's indented. Where we said that white space doesn't matter inside expressions, so I could say like 2 plus 2 or 2 space plus space 2, that part doesn't matter. This is the case where Python is very strict and absolutely cares. You have to indent this, or Python doesn't know what you're talking about. Because it uses the indenting to understand if you mean that this is supposed to be conditionally executed or always executed after the if statement. Okay, another one? Great. Okay, so we can either do something or not using if and a Boolean condition. What if we want to do one of two actions? So we need a new keyword for this, a new keyword called else. So we'll set this up with an example. We could say, okay, my sister is 15, and my brother is 12. And it starts out looking the same. We always start with the if keyword when we're making choices. So if my sister is older than my brother, colon, return, indent, okay. If my sister is older than my brother, then print this statement, return. In all other cases, so not indented, flush to the left with the if. In all other cases, colon, else, colon, return. And now we're going to indent and describe the work we'll do in the else case. In this case, we'll say that my brother is older. If my sister is older, do the work indented under the if. In all other cases, do this work. Okay, well, given the ages of sister and brother, what should happen here? Right, so we press return to end the line, return one more time to say that we're done, and there we go. Importantly, we can only ever print one of these. If this condition is true, we do this work and then we jump to the end. If this condition is not true, we go to the else catch-all, but we only ever do one or the other. Any questions about this? So great, with if and else, we can now take one of two actions. We may find that we want slightly more complicated Boolean expressions, sort of combining multiple pieces of input. And to do that, we have a couple of nice keywords to sort of combine, to have compound conditionals. So one of them is and. So I could say, okay, is 1 greater than 0, and is 1 less than 2? So just a plain old English and. And we're really asking two questions. Is 1 greater than 0, and is 1 less than 2? And when you use and, we say, what happens is we evaluate each of these conditions, and if overall all of them are true, the overall result is true. And then in all other cases, it's false. So I could say, if 1 is less than 2 and x in ABC, well, in this case, I need all of them to be true for the overall expression to be true. So this one evaluates to false. And we can chain this as much as we want. So we could say A in ABC and B in ABC and C in ABC. You can have as many of these ands as you want, and they just chain together, a bunch of Boolean expressions. And we can also use or. And or says at least one of these is true. Is it the case that at least one of these Boolean expressions is true? So, is A in hello, or is E in hello? And so long as at least one of these is true, the overall expression is true. Cool. Okay, so now that we have these compound conditions, we can have sort of more expressive choice making. So for example, let's say, okay, well, the temperature is, I don't know what it is in Celsius, but it's probably about 32 degrees right now. You know, it's 80 in San Francisco right now. What did I leave there for? Okay, so it's 32 degrees right now. If the temperature is greater than, let's say 60, and the temperature is less than 75, colon, return, indent, you know, room temperature I can deal with. So if the temperature is greater than 60 and the temperature is less than 75, and a common mistake I'll point out here is you have, like, each of these has to be a complete expression. A thing that people often want to type is if temp greater than 60 and less than 75. You can't do that. You have to, like, treat these as independent things that are getting evaluated, and that will help you remember to use the variable in each of them. Okay, so if temp is greater than 60 and temp is less than 75, print nice and cozy, return, no indent, right? Else is flush, it's aligned with the if. So what should print here? Exactly. Yeah.
So I had made a typo and I had already gone to the second line and I can't go back to the other line. Is that just because of this particular module we're running right now, which kind of helps us do things?
Yeah, good question. So, like, let's say we make a typo in here. Like, maybe I leave off one of the quotes. There's not an easy way to fix it at the interactive interpreter. It's just sort of a bummer, you're going to type it again. The real answer to this is we won't write anything longer than this here. We'll move to files for more interesting programs. And in files, all you have to do is save, you know, make your change, save it, and then run it. So we're only going to suffer for a little while longer at the interpreter while we learn some of these concepts. Yeah. Okay, so now we know how to take one of two actions using if and else. Great. Okay, well, a natural question is, what if I want to, you know, do one of three things, depending on some condition? Like, how do I extend this to more outcomes? And we need one final new keyword to be able to do this. This is called elif. And we'll talk about this by way of an example, actually. So if we scroll back up to this example here, this example is a little bit of a lie. So if the sister is older than the brother, the right thing happens. If the brother is older than the sister, the right thing happens. What happens if they're the same age? What do we print? Yeah, so let's say the sister is 15 and brother is 15. Is 15 greater than 15? No, right? So the if condition isn't true, we go down to the else and we do the else work. So if they're the same age, we actually say that brother is older. So kind of a lie. Let's use this new elif keyword to correctly handle the case where they're the same age. So let's, well, you know, for the sake of exercising the code path, we'll say that the sister and the brother are both 15. Oops. Okay. It's going to start out the same. We can say, okay, if sister is greater than brother, colon, return, indent. But here's where it changes. So if condition do work, if it's not true, check a new condition. So if this one isn't true, go to the next condition to check. Elif sister is the same age as brother, colon, return, indent. Return, and then we still can have a catch-all. There's only one other option, right, which is that the brother is older. We can still use our else to handle that catch-all case. So else, colon, return, indent. Okay. So what is sort of stepping back, what is the overall structure here when we're making complicated choices? It always starts with an if. If has a condition. If this is true, we execute the work indented under the if and then jump to the end. If it's not true, we'll try to go to the next condition to check. So we might have, and we can have as many elifs as we want. So elif is like each new condition in a row that we want to check, hoping to find one that ends up being true. So elif sister equals brother. And then else is a catch-all. Else does not have a condition associated with it. And you can have just an if you want. It sort of depends on what logic you're trying to express. We could have just an if, and then we're either doing something or not. We can have an else as a catch-all if we always want to do something as a catch-all. And we can have 0 to infinity elif, not really infinity, but 0 to as many as we want elifs to handle sort of checking multiple conditions. So you always have an if, you have 0 or 1 of these, and you have as many as you want of these. Okay, given the ages of sister and brother, given what we've written, return to end the line, return one more time to say that we're done. There we go. And in your handout, this is like a pretty sophisticated structure, right? In your handout, there's a little diagram to help remember which is the one that takes a condition and doesn't, and the order and the indenting. Okay, so this is good stuff. Booleans and making choices. Does anyone have any questions about this material? Yeah. Yes. So you have to start with if. The elifs are always in the middle. Or sorry, else is always at the end. The catch-all is always at the bottom. And so elifs would be in the middle if you have any of them. Yeah. Yeah.
Any ordinary switch statement?
There's no switch statement in Python. This is what you got, yeah. This person's programmed before. Other questions? Yeah.
So you have the syntax of if E in hello.
Mm-hmm.
How is the opposite if X is not in hello?
Yeah, so conveniently superhuman readable, so that you can do E, just in, in, hello. You can also say X not in, and it's just not in. That's how you spell it. Yeah. Anything else? Compound conditions? Good. Cool. So the only way to actually digest this material is to start going through some practice problems to get your fingers working, get your brain breaking down the problems and solving them in Python. So that's what we're going to do next. So let's see here. Here we go. So for the next at least 15 minutes, but we'll see how long we want to spend on this. We have some custom Code Academy questions written exactly for this class, practicing strings and choices. So if you please visit this link and then it's really the first section, which is 8 questions related to strings and choices. If you find yourself past camping trip or inexplicably dealing with lists, you've gone too far. So 8 questions related to strings and choices on Code Academy. And once you type in this URL, I'm gonna go and do the first one with you so we can see what the setup looks like. Oh, nope, that's not what I want. Really? Well, that's sad. I'm on the Are other people on the Wi-Fi? Fine. Yahoo.com. What's up? I didn't have to the first time. Oops. No, that was the wrong one. I know. Hold on. This is going to look really good on the video. Awesome. We'll edit this out. Okay, great. Okay, so here is Code Academy. And the structure of this site is there's an exercise description on the left. This is sort of the setup, and then here are the actual instructions for what you're supposed to do. And here's a scratch pad. This is sort of like writing code in a file, which we haven't done yet, but it's exactly the same as being at the interactive interpreter. You still have to indent, you still have to print, all of that stuff. So you'll have something that you're supposed to do. You're going to type it in here, and then when you've done the code you wanted to write, then you submit it. And it runs some tests, and if you get it right, it has a nice green checkbox. So this will help us sort of self-evaluate in real time if we understand what's going on. So here's the first one, and our goal is to practice printing numbers. And so far we have a variable called favorite number. Favorite number equals 111. And our goal is to use the print function to print the result of calculating favorite number to the 3rd power, which we've even basically already done. And then so we print that on line number 2, and then we'll save and submit it. So there are really two pieces to this. So the first one is, how do you do something to the third power? And we talked about this earlier. You could say favorite number, star star, 3. And so that would do the calculation, but the other thing we need to do is print it. And we use that print function with the input inside parentheses to print it. So it looks like we've completed the instructions. There are hints at the bottom if you ever have questions. Given that we think we've done the work, we can save and submit our code. And ignore the none, this is like a bug in Code Academy, but the first line is what was printed, is our output, which was the correct answer, and it says it was. So then we click Start Next Lesson. Now we're on number 2. And so there are 8 of these questions that we'll go through to practice strings and choices. And the helpers will float around as you go through these Code Academy exercises. Okay? Any questions before we get started? Cool. Okay, have at it. This is a really important time to solidify this material mentally, so definitely please do. Cool. Okay, we are going to continue right along then. So the next part is going to be another sort of interactive lecture, and we're going to talk about lists and loops. And this material is, again, in your handout if you need a reference. But we're going to flip back over to our terminal, and if we need to, we may need to start Python again. And once you've done that, we will get started. So far we've learned about a bunch of really useful data types, but they all represent sort of individual pieces of data. So you have a number, a string, a Boolean. But what happens if you need a collection of pieces of data? So let's say that I'm a scientist and I've run some experiment, and that experiment generated a bunch of numbers, and like over time, and I wanted to store them all together. How would I do that? Well, there are a couple of data types in Python that are relevant to this idea. The main one that we're going to talk about first is called a list. And a list is really good at storing ordered collections of data. So we're going to play with lists for a little while. The way that you create a list is like this. So please type along with me. So your list, so just a variable name, and then an equal sign. And then when you're creating a list, that's sort of the signal that you're creating a list is that you're using square brackets. So it's a comma-separated set of items inside square brackets. So here we're creating a list called your list that has 3 items, the string A, the string B, and the string C. And we can confirm that this is a new type that Python recognizes using that type function. Lists can contain anything. So it could contain strings, it could also contain numbers, it could contain booleans, it could contain a mix of things. It's really up to you for it to express the thing that you're trying to express in code. Like strings, lists have a notion of length, and you can use that len function from before to get the length of a list. Also, like with strings, lists have a notion of containment. So we had said, oh, is E in hello with that keyword in? You can use that same keyword with lists. So I could say, well, is A in your list? These return a Boolean. Yeah.
As far as the commas go, does there need to be spaces in between the quotation mark and the comma?
Good question. I don't think so. We can always experiment with this. So I think the question was, like, what if I did this?
Yeah, does that matter?
Looks like it doesn't.
Okay.
And in general, sort of in between parts of an expression, Python doesn't care. It's only with the indenting that Python cares about white space. Good question. Okay, so lists. We can create them. They have a length. You can check for containment. We can access individual items in this list using kind of a funny syntax, which we'll do it and then we'll talk about why it looks the way it is. So let's say that I wanted to get the leftmost item in your list. The way I would spell this is the name of the list, and then inside brackets, the index of the item. And you'll notice here that I chose as an index 0, which is maybe a funny way of counting. So a reality, just a truth about Python is that we start counting at 0. So the leftmost item is 0, the next one is 1, and then 2, and then 3. And that's going to make some of the math that we do a little bit interesting, but this is just the way that it is. So the leftmost item in a list is 0, the 0th index. So here's how we pull out the A, similarly the B. Remember, you can use the up arrow to go back and edit and re-execute previous statements. So here's the first, quote unquote, first item, the second. What do you think happens if we try to get the 0th first, second, third item? Yeah, so we only have A, B, and C. So what does Python do here? Oh, we get a traceback. Fair enough, we've seen those before. But pretty readable message. There's an index error. The list index is out of range. Fair enough. Well, fortunately, we can add items to the end of a list. And the syntax for this is a little funny as well. So we'll do it and then we'll talk about it. So we have your list. We have the name of the list. And then the syntax here is a period, the name of the function, which in this case is append. And then it's a function, so we know it's going to have parentheses, and inside the parentheses, the item that we want to append. So the name of the list, a period, the function name, and then the input inside parentheses, the thing that we want to append inside parentheses. So if we do this, press return, type out your list, we see that it has in fact grown a D, and the length reflects this. And we could now, if we want, take the 0th first, second, third item from this list. And so why is this syntax different from, like len is a function, why is there no period len thing going on? And the story behind this is a little complicated and will become clear as you continue learning Python, but the gist of it is that lists have lots of operations that are associated specifically with lists. Like you can append items to lists, you can pull items off of lists, you can look for items in lists. These are all sort of functionalities associated with lists, and the way that we spell that it's a function of a list is with this dot name syntax. Whereas len, as we've seen, sort of applies to lots of things. You can use it on strings, you can use it on lists, and possibly even some other things we haven't covered yet. Len is this more sort of general accessible function. Hand waving a little, but to remember the syntax, it's sort of like lists have various functions. It's dot function name on a list. Okay, well here's a question. How would you create an empty list, given what we know about lists? Yeah, right, so we said it's a comma separated set of elements inside brackets. If we have no elements, it's just bracket, bracket. And then the len is, of course, 0. We can replace items in a list. To do this, why don't we build up a list of names here? Let's say that we're starting a band. So that Alice and Amy, they're singers, starting a band. They've realized that they need a guitar player. So Adam is going to join them on guitar. Rock out, Adam. Adam actually plays bass, not guitar, whatever. Anyway, we're going to add Adam to the band. We're going to append him to the end of this list. If we look at names, sure enough, he's at the end. But now we could say, okay, Alice is spending too much time with the groupies. Alice is out. Jimmy is in. How do we replace Alice with Jimmy? And the way that we spell this starts as if we were sort of pulling out the items. So the way that we would pull out Alice is we would say names, and then inside square brackets, the index. And we know that it starts at 0, so the 0th item. So we know this is how we would pull out Alice. But then we, sort of carrying forward, then we do an assignment to the thing that we want to replace it with. So replacing Alice with Jimmy would look like this. So if we do this, and we look at names, we see that sure enough, Alice is out, Jimmy is in. Is there a hand raise? Maybe? Nope. All right, maybe Adam is not cutting it on guitar. Adam is out. Rachel is in. 0th first, second. Assignment. New item. Dana looks like she has a comment. No? Yeah, I've kicked out Adam of this band. Sorry, hun, it's not working out. Here's a question for you. There's this, and then there's this. How are they different? Yes. So equals equals is still a comparison. This will evaluate to a Boolean. This is an assignment. So always keeping that in mind. We can add a couple more people to this band. We can add maybe a horn section. Maybe Tim is on sax. Maybe Bob is on French horn. Alexis is on trumpet. We have a nice long list of names. I like that line of reasoning. Okay, so one question is, what if we wanted to append a bunch of stuff? A related question might be, Jessica, how did you know that this appending is a thing that you can do on lists? Like, or what can you do on lists? What are all of the things that you can do on lists? And a good thing to internalize right now is that programming is not about memorizing things. Like, a good strategy here is not to try to memorize all of the things you can do on lists. Programmers first off, programmers are notoriously lazy. Nobody does that. My memory is terrible, and I definitely am lazy. And what happens is we rely on documentation to tell us what we're able to do with different data types. And looking up what you can do, there's like no magic around. We're going to do it right here together, actually, to make a point of this. It's really not very interesting at all, actually. So what we're going to do is we're going to go to our favorite web browser. Then we're going to go to our favorite search engine. And then if I wanted to know what you can do with Python lists, here's what I would do. I'd say Python list. And I'd press return. I would take the very first entry, which happens to be an official python.org entry. And I would see what it says. And here we go. This takes us to the page that enumerates all of the things you can do on lists. We see our append function here. Your question was, can we add a bunch of items to the end of a list? And I think what we would do in this case is we would use the extend function, which allows you to sort of smoosh two lists together, add one to the end of the other. We can insert items at various places in the list. We can remove items. We can look for the index of an item. We can count how many instances of an item there are in the list. We can reverse them. So all kinds of useful stuff. And definitely we wouldn't memorize this. We would remember the general syntax, which is that you have, a variable dot function name, item in parentheses. But other than that, we would just look up what's possible. Yeah. So yes, so that was definitely a programmer question. So let's say that we're on an airplane and we don't have access to the internet. There is some sort of built-in help. Let's do help first. So there's a help function, and you can pass help a variable, and it will tell you about it. This is not that pretty looking, but it does. It has lots of information, some of which we might not care about, and we'll eventually get to the items that we do care about. Like append, here we go. There's append, there's count, there's extend. If you typed in help with me, you might be saying, hey, how do I get out of help? And this is not intuitive. You would press Q. Q is how you get out of help. So help is the way to get sort of long form documentation inside the interpreter. There's also a dir function, which, again, you can pass any type of variable, and that will give you the names of things as opposed to the names and definitions. So if you just want like a short form reminder of what it's called. So dir and help are the in-interpreter options. I basically, when I can use the web because it's formatted more nicely, would use that. Yeah. Good questions all around. Any other questions related to looking stuff up? The answer is basically Google for it. And if you're ever wondering, like, is it possible to do such and such thing with Python? Like, you would just Google for it, and the answer is almost certainly yes. Let's see here. Okay. Okay, so lists. We know how to create them. They have various interesting properties, like a length. We can append things. We can replace things in lists. Any questions about that? So here's a question. What if I wanted to get the last item in a list? So like I wanted to pull out Alexis. We know how to pull items out of a list based on their index. How would I get the last item? So, so one thing, so let's pretend that we didn't have that intuition and actually go through the work. So we know that to get the leftmost item, we would use 0. How do we, just using the logic that we already know, find the last index of the list? We know that we can take the length of a list, yeah. So we can take the length, and let's see here, we have 1, 2, 3, 4, 5, 6 items in this list, but we do start counting at 0. So really it's like 0, 1, 2, 3, 4, 5. So the way that we might compensate for the 0 is we might say a len of names minus 1, right? So we could take that and use that as our index. And this would give us the last item in the list. But as some astute folks in the audience pointed out, why don't we just use, like, some Python developer was like, hey, why don't we just use negative numbers to start counting from the end? Which is, that definitely makes sense, right? So -1 actually is the same way of expressing this logic. And you keep sort of counting down if you want. So -2 by extension gives you Bob, -3 gives you Tim, etc. That's kind of cool. But all it's really doing is this. So there's no real magic there. Yeah, so there are tons of useful functions. One of them is called pop, which if we just sort of try it and see what happens, we see that it spits out the name Alexis, and then it actually removed Alexis from the end of the list. So depending on what logic you are writing using lists, that could be really useful. And this sort of indexing syntax, we found that strings and lists are pretty similar. Like conceptually, strings are an ordered set of characters, lists is an ordered set of whatever you want. So a lot of the same operations are supported for both. We know that they both have lengths, for example. You can similarly, if I said my name is Jessica, I can use this indexing syntax on just strings as well. Let's call this more meaningfully name. So I could say name 0, and what is the 0th, item, really character in a string? Well, it's the letter Jessica. What is the -1th? It's the A. Okay, so a quick review of lists. So the way that we would create a list is we would give it a name, and then inside square brackets, we would initialize with a comma-separated set of items. So here is a list with 3 items, each of which is a string. We know that we can use this index inside square bracket syntax to pull out individual items. We know that we can use negative numbers to pull items off the end of the list. We know that we can do assignment. We can replace items in a list. So if I wanted to replace the 0th item, apples, with perhaps plums, it would look like this. So pull it out and then do an assignment. We know that we can add items to the end of a list with that append function, that dot append syntax. We know that we can take the length of a list. We can do things like check for containment. Cool. Does anyone have any questions about lists? Yeah. Yeah, good question. So can we grab more than one item from a list? Yeah, sure, we can talk about this. Oops. So, and the syntax is kind of interesting. Like, just if I were thinking about how I would design this, I think this is interesting. So the question was, what if we wanted to pull off, like, the first 2 items in the list? How would we spell that? Well, we know that this is how we would pull off 1 item. The way that you say a range is with the lower bound and then up to but not including some upper bound inside the brackets. So 0:2 will pull out 0 up through but not including the 2. And so similarly, I could say, 2 up to 3, up to but not including 3, which would just give us this 1. And what's kind of fun about this syntax is that if you want it to start at the beginning, you can, the left one is implicit if you want to start at the beginning. So instead of saying 0, you could just leave it off. And then similarly, if you wanted to start at 2 and go to the end, instead of having to do the calculation on what the actual final index is, you could just leave off the trailing index. And then by extension, if you wanted to make a copy of a list, a really succinct way of doing that is actually just to do this. So no lower bound, no upper bound. Make a full copy of the list. Kind of fun. Other questions about lists? Ordered collections of data. Cool. All right, well, lists are great, but the real power of lists comes from the ability to loop over them. So this is my favorite topic of this whole 3-hour session, and we're going to talk about looping over lists next. Okay. Let's give us a new list of names just so we have something to work with. Let's say we have Alice, and we have Bob, we have Cassie, Diane, and Ellen. Okay, a nice list of names. What if I wanted to loop over and do some action for every item in this list? Like rather than typing it out for each index in the list in turn, because we're lazy. Remember, programmers are lazy. The way that we do something for every item in a list is with a construct called a for loop. We're going to do this, and we're going to talk about why it looks the way it does. So we could say, okay, for is our keyword. For, and then a variable name of our choosing. So name is a variable that we're choosing. For name, keyword in, and then the list name. So for variable in list name, colon, return. We've seen this before. The prompt changed. Python knows we're in the middle of something, and that we're going to indent. 1, 2, 3, 4. Everything that's indented is going to happen for every item in this list, where name is going to be a variable pointing to each item in turn. In this case, let's just print the name. We're just going to print the name. Return to end the line. Return one more time to say that we're done. There you go. What's actually going on here? Names is a list. Name singular is a variable that we chose. Python sets up this loop that says, okay, first name is going to point to the leftmost item in this list. First name is going to point to Alice. And you can use that variable indented inside the for loop to act on that variable. So first, name points to Alice, and we print the name. We go back to the top of the for loop. Name is going to advance to the next item. Now name points to Bob. Now we're going to print Bob. Go back up to the top of the for loop. Now name points to Cassie. Print Cassie. All the way through until you're done, until you've gone through every item in the list, and then you're done with the for loop and you move on to the next de-indented line of code. Now to hammer home that this is a variable name of our choosing, let's do it again with a different variable name. So we could say, okay, well for x in names, colon, return, indent. Okay, I want to print every name in turn. How do I do that in this case? What do we print? We print x, right? So we pick the variable name. That's the name that we have. That's the variable that we have to use to do work on the item inside the for loop. So for x in names, print x. Exactly the same. Okay, well, let's expand this a little bit. What if we want to make it a little bit more interesting? We can say, okay, well, for word in names, colon, return, indent. You know, we can still have arbitrarily complex statements indented here. So I could print hello with a space plus what? Whoa, word. Hello plus word, variable that we chose. And we could have as many lines as we want. So just like with if, as long as we keep them indented, Python knows that we mean for them to be applied each iteration through the for loop. So here we could print hello plus a name. Let's think about what that's going to produce. Then we run it. Cool. Any questions about sort of the structure? So for variable in list, colon, indent. Okay, here's a tricky question for us. What if, in our list of names, what if we only wanted to print out the names that start with a vowel? I like where we're going with that. So let's deconstruct this. So our goal here is to use a for loop to print out only the names that start with a vowel. So question number one is, how do we check if something starts with a vowel? So let's say, okay, name equals Alice, just as a little test case here. So name equals Alice. How do I determine if name starts with a 0? Okay, well, starts with, the way that we find the character that it starts with is using this bracket syntax before with the index, right? So this will pull out the leftmost character in a string. Cool. And we want to know if that is a vowel. How could we do that? What are some thoughts on this? Well, and so we're doing some sort of check here, right? Exactly. So we have this character, and we really want to know if it is an A, an E, an I, an O, or a U. And there are a bunch of ways we could spell this. We could say if it equals A, or if it equals E, or, and so on, right, until we do all of them. We could also say, is it in this set of characters? Is the capital A contained in this set of characters? We could even say, is it in this list of characters? So all plausible options, I tend to go the shortest route, within reason, because it's less to type. But all of these would express the same idea, which is the leftmost character contained, is it a vowel? Is it in this set of vowels? Okay, so we know how to check that. Now we need to sort of embed this inside the for loop. So first let's set up the for loop. We'll say, okay, well, for name in names, colon. So the setting of the for loop looks the same. Return indent. But our goal was to sort of conditionally do something, right? We're only going to print the names that start with a vowel. And when we're conditionally doing something, that means we're making a choice using if. So we're going to need to use that if from before. So if the name starts with a vowel, if name 0 in A, E, I, O, U, colon. Now we gotta be careful here with what we do next. So we press return to end the line. We need to indent inside the for loop, but we also need to indent inside the if. Okay, and now we're in the case where this is the stuff that gets executed only if this condition is true. So what we want to do in that case is print the name. So you can say print, name starts with a vowel. Okay. If the name starts with a vowel, do this indented work. Return to end the line. Return, well, let's think about what's going to happen here. Given what names looks like, given this logic, okay. Return one more time to say that we're done. Cool. We did what we said. And what's really cool about this, what's really amazing about this is that the amount of work that we have to do here is independent of the length of the list. So this list could have had 1 billion names in it, and we wouldn't have had to do any more work. Like, that is what's amazing about for loops. And this is what's amazing about computers, right? It would do this work instantly, basically regardless of how long the list is. Okay, so really cool. And so a couple of key ideas here. You have for loops, awesome. You can have whatever you want indented inside for loops, including if statements, including other for loops even if we want it. Just whatever we need to express, it can be arbitrarily complex. Okay, well here's a question. What if instead of printing the names, we wanted to build up a list that contained only the names that start with a vowel? How would we do that? So names starts like this. We want to build up, so we don't want to print anything. We just want to build up a list containing only the names that start with a vowel. Well, we're going to want a for loop. It sounds like we also need some storage. Like we need a second list that we're going to add things to as we go through the for loop. So let's set up that storage ahead of time. So vowel list, or vowel names, equals just, it's empty. Okay, so we're setting up the storage ahead of time. Now we can loop through our names again. Say, okay, well, for name in names, colon, return, indent. Our check is the same, right? We still want to see if it starts with a vowel. Same way, if name 0 in AEIOU, colon, return, indent inside the for loop, indent inside the if. But now what do we do? Our goal is not to print. Our goal is to build up this list. And the way that we build up a list is we can use that append function from before. So we can say, okay, vowel names. So in the case where the name starts with a vowel, add this item to the end of vowel names. What goes inside the append? Name. The variable name that we chose that represents each item in turn as we go through the for loop. Okay, so for name and names, if it starts with a vowel, append it to vowel names. What should happen when I press return? What should be printed? Nothing. There is no print statement, right? We don't print anything. All that happens is that we have added things to vowel names. So now if we check vowel names, sure enough, it contains our vowel names. So this is cool. And so the big idea here is that sometimes you need to set up some storage, maybe set up a list, before the for loop that you can then use inside the for loop. Here's a question. Let's say that I am going to the grocery store and I've bought, like a pack of gum and some milk and some bread and like a toy. So I have sort of the cost of a bunch of goods that I've purchased at the grocery store. What if I wanted to add up all of the items, the cost of all the items using a for loop? How would I do that? Well, it's sort of like keeping a running total, right? I'm sort of starting at 0. I'm going to add each cost, going through each item in the list until I get to the end of the list, and then I have this running total that should contain the overall total of what I paid for. So again, I need to set up some storage ahead of time. Really, I have a total that starts at equal to 0. And now we set up our for loop. So we could say, okay, well, for cost in prices. Cost is a variable name of our choosing. Colon, return, indent. So cost points to each number in turn, and I want to add it to this running total. And so to add it, I would just say total plus cost. But really, I want to store it back in total. Like we're going to keep updating total with the new value. And the way that we do that is with, it looks kind of funny, but when you think about it, it makes sense. We say, okay, we add total, this new cost to total, and then we store it back in this existing variable that we're using. Okay, so for cost and prices, add the cost to total. We don't print anything, but if we execute the for loop, and we look at total, there we go. Summed up all the items in this list. Again, we're using this idea from before where sometimes you have to set up storage before the for loop that you use inside the for loop. Now, I'm cheating on you guys a little bit here because there's a function called sum that will do the exact same thing. So we would probably use that instead in actual programs. But cool. So loops, super powerful. Like loops took us to the moon. Loops are really important. Anyone have any questions about lists, how lists interact with loops, appending to lists, this idea of storage that you build up? Questions about any of this? Cool. And then looking things up is the other really, really, really important thing. There is documentation. You look it up online. You can even use the internal help if you want. But don't be afraid. Like, in general, be comfortable with not knowing things. Like, the reality that you will need to look stuff up is an important part of growing as a programmer. And it's totally great, and you totally get used to it, and you get practice. Cool. Okay. The only way to really learn this stuff is to practice it. So we are going to flip back to Code Academy for a couple of minutes to do a little bit more practice. If I could find that practice. So we're going to go to the same link from before, but to the second section. There's a section devoted to lists and loops, and please start working on the problems in that section. Sorry, here's the link. And so how you might navigate to this is, like from this sidebar here, there's a lists and loops section that you can navigate down to. Oh, sorry, this is really low. Down in the left corner, there's a lists and loops link. Yeah. Cool. All right, so then next, at least 20 minutes, we're going to do some lists and loops practice, and we'll be circling around to help people, okay? Cool. Okay, so I want to do just a couple of fun things to wrap up here. So one is that, and the purpose of these is both just to have a little bit of fun and to show that you can get some pretty useful work done in Python with not very much code and not much beyond the concepts that we've already learned. So one example of this is, do people here play Scrabble or Words with Friends? A little bit? Yeah, geez, not very many of you. Fine, okay. Well, anyway, if you play Scrabble or maybe you play Scrabble at home, looking up Scrabble words and words with weird properties is really easy in Python using just the concepts that we've already learned. So here's one example of this. And this is some Python code in a file, which is a new thing for us. Some folks have been playing with files a little bit already. It works exactly the same way as running things from an interpreter, except that it's sort of all in a file, and you run the file, and you use Python to execute all of the contents of the file. And it's easy to save and edit. So this is how you do actual useful work in Python. How do I change this? No. Select. It's better. Okay, better. Great. So this is just Python code in a file. And then there's this import keyword, which we haven't talked about yet, but the point of import is that you use it to gain access to additional functionality in Python. So there's some core stuff that you just have access to, like len just exists, lists are just available to you, but you can use import to gain access to additional functionality. And this is also how you would like if you wanted to write a script that interacted with Twitter, for example, like there's a Twitter Python module that you would import to get access to the Twitter functionality. So similarly, this is a module that gives you access to some Scrabble-related stuff. And in particular, inside Scrabble, there's a list called word list. And this is just a list containing, in alphabetical order, all of the valid Scrabble words. According to the Saupods Scrabble dictionary, which if you're a Scrabble nerd, you might care what dictionary you're using. And the point is that there are lots and lots of words in the Saupods dictionary because Scrabble players want to have as many options as possible for scoring points with bad racks. So the Saupods word list contains a ton of words. It contains like 270,000 words. And all of those words are in this word list. And given access to this word list, we can ask some kind of fun questions. So like classic Scrabble problem, it's like the end of the game, and you have a Q in your rack, and you don't have a U. How screwed are you? right? Like, what are all of the words that contain a Q but not a U that you might be able to play? How would we answer that question? Well, given access to this word list, we can write a pretty simple for loop. We could just say, okay, well, for every word in this list of Scrabble words, let's start with a simpler question. For every word in this list of Scrabble words, what if we want to first answer that question? Are there any words that contain UU? So like I know vacuum contains UU, but are there any other words? Can anyone think of any other words? No? Well, hopefully there are more because we need more for our Scrabble rack. So our goal here is, okay, what are all of the words in the Southpod Scrabble dictionary that contain UU? For every word in the list of Scrabble words, if UU is in the word, print the word. And if we were writing this in a file, we would save it. And we did some command line navigation in the prep for this class. So if I've navigated over to the directory that contains my words.py file, I can run it with words.py. And this will print the logic from the program. So here are all of the UU words. So actually some pretty good options here. Continuum, squash, pretty good. Okay, so it was really easy to answer this question. What are the words that contain UU in the Scrabble dictionary? Now a related question is, what are all of the words that contain Q but not U? How can we use this framework to answer that question? What is our if condition? Yeah. Yeah, exactly. So we can use those compound conditions, right? We can use that and keyword. If Q in word and U not in word, print the word. Okay, we save it, flip back to our terminal, we can run it, see what we get. Okay, so definitely some options. QI, that's a classic. So if you're at the end of your Scrabble game and you're stuck with Q without U, you definitely want these words in your back pocket. Cool. How about this? What if I wanted to know all of the words that start with AA? Like I know aardvark is a word, but are there any others? How would we spell that? Starts with? We've thought about that before. If word 0 starts with A, and the next one is also an A, print the word. Let's try that. Okay, in addition to aardvarks, we have aardwolves. This is where you can tell that Scrabble players are getting super desperate. Like, sure, those are all real words? Okay. Okay, so some options here, pretty good. Here's a question. What are all of the words that contain all of the vowels? So A and E and I and O and U. How would we spell that? And really there are a couple of ways we could spell that. It's a little bit of typing, so I typed it out here. So you could say if A is in the word and E and I and O and U, print the word, right? We try this. Oh, sorry. This is in words2.py, so let's run words2.py. And just all kinds of really good words containing all of the vowels. Lots of words. We could ask a related question, which is all the words that contain no vowels. And how would we adjust this script to say no vowels? Not in, right? All right. This definitely happens in Scrabble sometimes. What are our options here? Okay. Some of these are looking a little fake here, Scrabble players, but okay, I'll take it. Cool. And what's nice about this, I mean, part of what's cool about this is that we're answering questions that potentially you couldn't get an answer to before computers. Like, how would you do this? Like, you'd have a monk in a monastery who'd spend his whole life answering this question, and a computer can do it in effectively no time at all. That's pretty cool. Okay, so a little bit of wordplay. A couple more quick examples. So true story. I do play Scrabble at home. In particular, I play Scrabble when I come home for the holidays with my dad. And so we were playing Scrabble one day, and my dad is like, oh, I have to go to the bathroom. So he goes to the bathroom. And he's sort of gone for a while. I'm like, oh, what's going on here? And then mom comes in. She's like, oh, hey, dinner's ready. And I'm like, okay, I'll go tell dad wherever he is that dinner's ready. So I'm looking around for him, and I look into, he has like a little studio, and I look in the studio, and I sort of peer in, and I see that he's not at the bathroom. He's on his computer. And what is on his computer screen? A web page that has a list of all of the 2- and 3-letter Scrabble words. So my dad, my own father, has lied to me and has escaped to look up the valid 3-letter Scrabble words so he can try to play them against me in our Scrabble game. Like, what kind of world do we live in? Okay, but here's the problem. So if your daughter is a programmer and you're going to cheat at games, that's going to get you into some trouble because I'm just going to cheat harder than you, right? So what I promptly did is I wrote a program that will assist me when playing Scrabble against my father. And we can even open it up. We don't have to understand every piece of this, but sort of the point of this is to illustrate that with not that much code, you can do some pretty useful work. So this has some concept that we haven't quite learned yet, but if we just sort of scroll up and down, we see it's maybe, 40 lines of code. We see a bunch of things that we have learned. We have for loops, we have if statements, we have booleans, a bunch of concepts that we have learned. The main new thing that this incorporates is it has the ability to accept arguments on the command line. So the way that we would run this Scrabble cheater is we would provide the name of the file, but then additionally, as a command line argument, we'd provide a Scrabble rack. So like what tiles I have to play in Scrabble. And what this does is it takes the rack and it computes the best things that you can play with that rack and their Scrabble scores. So like if I have A, B, C, D, E, F, G, the 2 best words that I can play are decaf and faced. And so, armed with this script, my dad is really never going to beat me at Scrabble ever again. So, pick a couple more good ones, maybe. What can we do here? Zooks. Excellent. Definitely was not going to come up with that on my own, right? Cool. Okay, so Scrabble cheater, 40 lines of Python. Pretty good. I would say with like maybe 2 more hours of studying on these particular concepts, you would be able to write this. Like, no problem. Okay, and then one final example here is one that a couple of people have been sort of working through a little bit, which is a state capitals quizzer. So if anybody here has kids, and the kids are like, hey, mom or dad, I want you to help me study for my exam. You're like, no, I've written a program that's going to help you study instead, because I'm going to go do other things. So here's our state capitals quizzer. And again, it's actually pretty short. The vast majority of this script is this sort of chunk of text at the top. And this chunk of text is part of a data type that we haven't talked about yet. It's called a dictionary. And it's just another container data type, and the main point of dictionaries is to store key-value relationships. So given a key, like a state, look up a value, which is the capital. And what this quizzer does is it loops 5 times, and it randomly selects a state from this set of states. It looks up the corresponding capital, and it prompts the user for some input. Another cool idea, which we haven't had time to explore yet, but would be easy to look up on our own. So we prompt the user for some input based on a question. What is the capital of some particular state? We use an if and an else to check if they've provided the correct capital. If they have, we say it's correct. If it's wrong, we give them the actual answer. And we loop 5 times, and then we're done. And that's all there is to it. But a pretty nifty little script and a good template for lots of other use cases as well. So let's go ahead and run this and see what it looks like. So I run statecapitals.py. And here we go. It's talking to us. What is the capital of Connecticut? Hartford? I see some squints. Like, I haven't thought about this in a while. Hartford. Okay. Oh, I bet what did I do here? I may have sneakily, hold on, let me. Okay. So what was going on there is that I had written this program in Python 3, which is a whole separate discussion we can't get into. We don't have time for it. But anyway, fix now, simple change. OK, so we're back in the program. What is the capital of Colorado? Anybody? Is it Denver? Probably Denver. Tennessee. OK, so actually my family lives in Nashville. This one I know, Nashville. OK, Oklahoma. Pretty sure that's Oklahoma City. One more. Come on. Oh, Come on, guys. Okay, Dover, Delaware. Okay, but so this is cool. Like, we're interacting with users. We could generalize this to really be quizzing us on just about anything. This would be a really great, like a great way to extend this would be to, instead of hard coding data in a dictionary, to read data in from a file instead, which again is really easy in Python. So just to get you thinking about, like, what are problems in your life that you want to solve with programming? They're definitely possible to solve in Python and not even in that much code. So, cool. Okay, so state capitals quizzer for you or your kids. Awesome. Okay, so those are just a couple of fun examples to wrap up. And then I want to, because we only have a couple of minutes, okay, spoiler. Nope, that's not what I meant to press. Quick wrap up. Because I want you to get your money's worth. There we go, okay, so we're gonna go up to the very end. Okay, hey, we did it. Yeah, our first 3 hours of Python. Yay, okay, awesome. So we've learned a really, you have a ton of really good context now for continuing to learn and practice the language. What's next? So realistically, pretty much regardless of background, there's lots that we know that we can do with Python. So if you've ever wanted to build a website, you're a scientist, maybe you need to analyze data, you want to stalk people on Twitter, they're all just, lots of really positive things for you and your community and your work that you can do using programming. The realistic next step for everybody in this room is that we can't cover every Python fundamental in only 3 hours. So the best thing for everyone to do is go through a longer form tutorial. You're going to be able to skip a lot of the content because we've already covered it. But there are a couple of data types we haven't learned about yet. Some really good stuff like file input and output that you're going to want to cover through a longer form tutorial. My preferred text in this space is called Think Python. It's actually written by a professor who sort of teaches people how to program for a living, so he definitely knows pedagogically a good way to do this. His name is Alan Downey, and he's a good buddy of mine. He lives around Boston, where I used to live. And Think Python, you can buy it, support Alan Downey, but it's also available for free online as a PDF. So go through this until you feel pretty comfortable with the language, and then the real next step to really take it to the next level is to pick a project and implement it in Python. So if you've wanted to build a website, if you have data you want to analyze, like pick a project, and you're going to have to look up some stuff along the way, but that's the best way to really get fluent in the language. And learning a programming language is sort of like learning, a spoken language. It requires pretty steady practice, right? So practice through a project that is engaging to you. So I recommend that you work through a self-paced tutorial like Think Python. I super recommend that if you have a local Python user group, that can be a really great resource. Sometimes the only thing that's wrong is you're missing a stupid colon somewhere and you can't figure out where, and like a second pair of eyes from your friendly neighborhood user group can be a really good way to get support. Pick a project and do it. It's the best way to learn, and make time for regular practice. All of today's material is online. I'll also post a wrap-up note through the Pycon infrastructure, so you have an email with a link to all of this stuff. And I'm totally happy to get feedback and questions, and if you want recommendations on texts or projects or things to work on, I'm totally happy to answer all of these things. So please do not hesitate to get in touch with me. As one final plug, I've written some books with O'Reilly, and they give away free stuff at their booth. And so if you want free stuff from O'Reilly, or if you have questions and you want an opportunity to come find me, I will be there at 10:20 a.m. on Saturday. And then will you please open up a web browser and take just 1 minute to go through the Pycon tutorial survey for this class. They would super appreciate it. I would super appreciate it. So I'm just going to sit here awkwardly for about 30 seconds, encouraging you to pull up this URL. Okay, I'm pretty convinced that you've at least got the URL open, so that's it. That's all we have. Please feel free to get in touch with me. Thank you so much for coming. I hope you have a great rest of PyCon, and I'm happy to sort of stay after class for any questions you have. So thank you so much, and a big round of applause to our 2 helpers, Adam and Dana. Yay. All right, you are all free in so much as please do the survey.